In this Flightstream tutorial, we are going to go over a sample setup for a ground effect simulation. The first thing we're going to do is create our ground plane using our basic shapes in the CAD Create toolbox. We'll select a new plane surface. We'll set up the plane in the XY plane. When setting up our ground effect plane, we want the width to be at least double the span. In the axial direction, the ground plane needs to encompass at least twice the length of the model upstream and 3 times the length of the model downstream. We'll swap the normal of the plane that we just created so that it's properly facing outwards, and then we're going to transfer the tessellation of our CAD sheet to the mesh. And then we're going to transform our sheet and set up our translation vector to shift forward by 2 meters and then downwards in Z by 1 meter. We shift the plane forward to properly capture the pressures ahead of the model. With this done, we're going to copy the plane in a linear pattern. We'll create 2 copies and then we'll translate downwards 2 meters for each copy. So one will be at 3 meters below the wing and one will be at 5 meters below the wing. Now we're going to rename each sheet accordingly. H represents the height of the plane below the wing, and B represents our total span. With those finished, we can set up our solver settings and boundary conditions. When we run a ground effect simulation, we want to use the default of pressure integration for our drag. We do not want to enable vorticity CDI boundaries. We're going to enable viscous coupling, and we're going to exclude the ground sheets from our viscous coupling calculations. We're going to enable airfoil flow separation on our wing. And then we are going to go ahead and initialize our solver. To properly capture the ground effect on the aerodynamic coefficients of our wing, we need to remove the ground plane from our total loads. Then we will execute the solver. First, we'll calculate the results for the ground plane at h over b equals 0.1, and then we'll capture the results for the baseline wing without any ground planes initialized. We can see that the lift coefficient for the baseline case is lower than that for the ground effect case. Here we have tabulated results for each of the ground effect simulations as well as the baseline case for angles of attack from 0 to 10 degrees. And we can see we have properly captured ground effect, where the closest ground surface creates the most lift, followed by the next ground plane, and then the furthest ground plane, and then finally the baseline of the wing only. And that's how to properly set up a ground effect case in Flightstream. Thank you for watching.